Okay, welcome to Open Source Antibiotics Series 2, meeting on Friday, November the 6th. Thanks for taking the meeting last time, and the recording is now on YouTube, so that's all there. I haven't had a chance to look at it this week, so it would be very good if we could just talk a little bit about what was discussed last time in terms of compound design. So just to very, very briefly bring people up to speed. So the issue for this meeting is up there, and we received a bunch of stuff on potency assays last time, 2 weeks ago. And in the last meeting, which I couldn't be at, unfortunately, you guys were talking about what to design and make for the next round based on these new data, which were pretty interesting. So I guess you guys spoke about that a little bit last time, and we can talk about what you were thinking about, and then we can make some decisions. Does that sound good?
Yeah, fine with me.
Okay. Did you guys have a slide or something of decisions or anything from last time? Okay, cool. All right. Do you want to walk us through it?
Yeah, so this is just compiling all the compounds from that issue. So yeah, the ones on the left are most straightforward. It's just, the same reactions. So I've made the parachloro.
Just one sec. Sorry, 1 sec. So the rationale behind those is arising from this
paramethyl
compound.
Yeah.
Which had the paramethyl, which was active, right? And okay, fine. And so you're obviously most of these are exploring that position with the same chemistry, which sounds good.
Yeah.
Yeah. Okay. And we didn't. Yeah. I mean, just based on what we already knew about that, so we've got this meta cyano group, which is inactive, and we've got this para CF3 group, which is kind of middlingly active. So I guess we just want to explore the para position, I guess.
Yeah.
I mean,
I think you have to be a bit careful about the log P of some of those compounds.
Right. Yeah. We need to have that tracked. Yeah.
I did track a couple of them. The top three are ones I designed. They're a little bit better than the talo one. But a couple on the bottom are pretty greasy, but
yeah.
The creeping log P is a problem in every campaign, I think.
Yeah.
Okay, sorry, Ed, do you want to just carry on what you were saying?
And then the rest of them are I guess slight modifications on the main structure. So I think Chris suggested this methylene dioxy bridged with the amine. And then there's putting the paramethyl phenyl on the 5,6 core, which we can do. These two in the bottom where we're removing one of the nitrogens, I think that's nice, but I think it'd be a lot harder to make.
I also think the one you have in the bottom middle will exist as a pyrrole. So it'll be the NH.
Yeah. So yeah, not sure about those. These ones, I guess we can make. I think we've started to make this methoxy core, and then this other one with the replacement heterocycle.
Yeah. So the thiazole is a bioisosteric replacement for a pyridine.
That's great. Mm-hmm.
I think the one on the bottom row, left-hand side, where you remove the nitrogen and the imidazole, it's just following on the idea of trying to explore whether we do need a bidentate ligand there.
Yeah. Absolutely. Yeah.
So I think it's a compound for providing information rather than increasing potency.
Mm-hmm. It's interesting because the one on the right in the middle bottom, the one you're just saying that would exist as the pyrrole, That also, if it had an NH, would not be coordinating.
That's correct, yes.
Quite neat, actually, as a tester.
So it's really a question of which is easier to make.
Yeah, synthetic difficulty, Ed?
I had a quick look at trying to get those cores, and I've not really found anything reasonable yet.
Okay.
Could you do, did you try and look to ones where you have the benzo ring on there instead of the saturated ring?
Yeah, I think I did, and it was
Okay.
similarly difficult.
Yes. Yeah.
What's the rationale, sorry, for the methoxy on the fused core?
Where's that?
Was that from a result? Oh, there was a set of activity. Oh, right, yeah.
There's a matched pair set in the D&DI compounds where one has the methoxy and one doesn't on the core, and the methoxy one is more potent. So I think I'd like to see if that trend holds, because I think that that's interesting.
Oh. Yeah, good. What about, is there value in, just looking at what we know here. So we saw that the paramethyl in the original set is the one with the activity. Is there rationale in moving that to the meta just to explore that space? If it's simple to make, just moving it around, because we're putting a lot on the para being useful here.
I think if you're going to, I think that sort of exploration is always worthwhile doing, but you know, the classical topless tree would start off with a chloro compound.
Right.
And just move it around the ring.
Okay, so I mean, if we can explore the isomers,
yeah,
that would be neat if that's synthetically straightforward. Yeah. All right, great. Any potential, what's the word, bottlenecks here synthetically? I mean, in terms of precursors and stuff, or is it's all derived from the same kind of chemistry, right? On the left in particular.
Yeah, just the bronic acids, I guess.
Yeah, okay. And have you chosen them in part because of that? I mean, because they're available?
Top 3 are available.
Yeah.
Top 4 are available. The more lipophilic ones are a bit difficult to come by, but you could probably make the one towards the bottom out of like parabromocumene, which I believe is available.
Okay. All right, good. Sounds good to me. I mean, it's all the most relevant things, isn't it?
Yeah, the SF5 is just me playing around.
Yeah, in my opinion, probably those bottom 3 are lower priority, I would say.
Yeah, they're probably the lowest priority of them.
Okay.
Although you could probably, I mean, although I guess we could kind of meet in the middle and say, if you have para-CF3 boronic acid, that would be something to see if lipophilicity has something to do with the way it works, but I'm not exactly sure because that's not going to be very soluble, is it?
I think in each case, if you can dump this slide on the GitHub issue, it'd be very useful with the log P's / log D's put in there. That would be very helpful. Also, if we start changing the core a little bit, like we have done on the right-hand side, just another quick check on SciFinder for anything that we may be hopping over to, sources of compounds or literature that we may have missed because we've been focusing on the left-hand side. Not sure there'll be anything there, but with the thiazole, for example, just check that we're not hitting something which has already been made in a different paper or project.
I think that if we could explore whether we do need that bidentate ligand, and then if that is important, you can think of a lot of things that you would replace the pyridine with, which could also coordinate and would have very different chemistry. Yeah.
Okay. I agree. Yeah, those are good ones for that too. So just on that point, about the toxicity, because that is absolutely going to be important here too, isn't it?
Yeah.
So sorry, Dana, do you have any update on the testing for the tox?
Yes. It hasn't been started. So Ed most recently has been in touch with Alex because she wanted to be today, but
yeah. So I'm gonna meet her after this meeting, and give her the 8 compounds.
Oh, awesome. Okay, great.
So yeah, I think it's like a 3-week turnaround or something.
Okay. Okay, that's great. Thanks for taking care of it. And obviously those are crucial. The thing that I'm thinking about with the potency data, this may be naive, but essentially all of these compounds have similar ability to chelate metal ions, and yet tinkering around with a remote site changes the potency. So it would seem to me that would argue against a generic toxicity mechanism. But the proof's in the pudding, right? But
Yeah.
Well, the MOA studies, then we can get people in to do docking once we know the protein.
Yeah, but what I mean is that I guess I would expect many of these to be.
Oh, I would expect if it was like a pains to just completely plow through all the cells and leave nothing behind. But I'm not sure. It's a very unusual core. The only thing that even remotely looks like it are the insomnia drugs, the Z drugs. The only thing that remotely even looks like that.
I think what you're saying, Matt, is absolutely correct if it's a generic toxicity. But of course, it could still be a specific mechanism for toxicity, which has its own SAR.
Yeah.
We just need the data.
Yeah. Okay, great. It was good that that's happening.
Is there any update on the MOA studies?
Oh, yeah. I don't think so, right? They're supposed to have been done, but we haven't checked it.
Yeah, I said I would follow up last time, and I have not done that. So I'll follow up with that this week.
Great. Yeah. Okay, so those are the most important things, I guess. And we are on top of them. That's good. So, Dana, you're non-chemistry this week, but I guess, Ed, you're still around holding up the fort and decorating the lab. All right, so just going back, if you wanted to, you got a chemistry update, Ed, if you want to. Cool.
Set up a few reactions, but these are all in my hood, just stirring at room temperature at this point. But it was just looking at whether we could make the methoxy core and then also with a chloro there, which we had sort of talked about last week too, by the same method that we're making, our other cores. So I've set those up. I need to deal with them when I come back. And then Ed suggested looking at the OSM, SNAR protocol to put the amine linkers onto this bromine core that we already have. So I've set that up too. If that doesn't work, I can try, there's several things I can try, maybe a Buchwald or something like that. So
maybe microwave.
Yeah.
So if there is a potential for a bidentate ligand there, if you were to put in something like zinc, would that coordinate to the nitrogens and make it more receptive to a nucleophile?
Yeah, nice. Yeah, I reckon that's a good idea. Worth a shot. Yeah.
Okay, yeah, that's another one that I need to check also. So I'll let you guys know when I get back in the lab.
If you want advice on the book about Hartwig, then just get in touch with Marat, because he's been all over this with examples of molecules with amines in them.
Cool. Yes, I'll do that.
Yeah, well, he's got all the conditions covered.
Nice.
I would have tried a Buchwald Hartwig, but that's going to be annoying, isn't it? For the top.
Depends. It's it's a mixed report in the literature about the influence of the pyridine and stuff. All right, great though. And Ed, you're in the bottom of the slide. You're muted, I think.
Yeah, so the left 3 compounds I made last week, so those are done, and then these other 2 with the chloro ones I did this week. So yeah, there's the parachloro one that suggested. And then, so we were thinking as well of putting the benzofuran on the core, but with the amine spacer. So I found a prep for this, but it uses this ligand, which I have to make, which is pretty easy, but yeah, that should get us that. And then we can put that on the core.
Okay. And then we want to see if that is, those 2 things are potent before we do any more of those.
Yeah.
Because it's a significant, 3-dimensional change.
Can you use that ligand and conditions for reacting the bromine with, say, an aniline as well?
Yes, sir. Yeah.
Yeah, for Dana's work.
Yeah, we can look at that. I think we should be able to make these amine spacer compounds using this core that we already have.
Yeah.
It's just a question of how exactly.
Yeah.
That is a neat ligand, the MNFO. I'm not familiar with it.
It almost looks like that compound that's in glow sticks. Forgot the name. Like something. Yeah, it's a dioxyl. It's like an oxalate.
That's neat. All right, great, very nice, cool. And with the 10% deal with the chlorine, you don't really care because you got enough.
Yeah.
Okay. All right, wonderful, good stuff. So just anything else that's left here? I mean, what we talked about is the most important things. Everything else is still there. I'm continually chipping away at everything else that's going on here. The MOA stuff is I think maybe the thing which we've got a pretty good expectation of getting something back on pretty soon. The other stuff here, I mean, Dane, you've got so much time now to make community updates. I've got to say it. So something, 30 seconds, 29 maybe.
Point taken.
And the only other thing that there was a mention of molecular contributions. Yeah, so how people might be able to contribute molecules. And I think from memory, were we talking about actual samples, Chris? Is that what you were getting at?
That is correct, yes.
Yeah. Right.
I mean, these types of structures, it would not be surprising if people don't have samples of this sort of thing in their sample collections.
Yeah. Yep.
So I've sort of made up like a draft spreadsheet. I was thinking if we wanted to set it up so that people could download it, it has all the shipping information on it, and it has, all the information that we would need. So I was thinking we could just like ask people to download that and fill it out if they wanted to donate compounds. It would all be sort of uniform and, easy to do, hopefully.
That's neat.
Yeah, sounds great.
It's the question of where to put it and how to publicize it, I guess.
There are two things. I mean, are we saying that we would be happy with molecules that humans are saying are related to the molecules we're interested in? Are we happy enough with that it's an intuition thing? Or do we want to say only if they're like 10 and they're 90+% or something?
I think if people are willing to donate them, I'd test them if you can.
And we need some basic level of agreement about what we're allowed to do, which exists already in the SGC probes program. So we can basically point to that page and say, if you agree to this, then you can submit compounds.
Yeah.
So we can include that link on it too. Danny, do you want to put, if you've got a spreadsheet, that sounds really good. If you could just start a new issue and dump it there.
Okay.
And then maybe we can come up with some text that we agree to about what it exactly is we're asking of people.
Yeah.
And I can put in a link to the agreement the SGC has that clarifies terms.
Yeah. Yeah.
So,
the spreadsheet and the license or the agreement were, in the same place and easy to find, then that would be good.
Yeah. Yeah,
can do
I mean, just so we can get everything together, so we're clear what we're saying and what we're going to send out, and then we can do that. And to be clear about what it is that we're agreeing to as well. So, you know, if people send a couple of milligrams, and if we use a small amount of it, and if we're left with the compound, we just need to clarify whether we're allowed to do anything with that, or whether we have a requirement to keep it. You know, those kind of little niggly things. It's as well to be really clear about all that before asking people to submit things. Yeah, ownership, essentially. But yeah, I agree, that would be really, really nice. Okay, I mean, I think that was everything else that needs to be talked about now. Everything else is kind of just sitting around bubbling in the background. I mean, just taking a step back for the big picture stuff, the purpose of this project, which is not meant to be infinite in length and expense, is to try and get us into a position where we are looking good to apply for follow-up funding for the project. And what that means is clarification on, improvement of the molecules to the point where they're looking interesting. Ideally, some information about MOA and some evidence that there is community interest in doing this project. So the contributions to molecules from the outside, from via Ben and DNDi, was really important. The idea of extra donations of compounds, again, would really help that. That by virtue of being open, people are happy to submit things. And I mean, the other data, we just have to try our best. But we do need to sort of put a little bit of a ring around it to make sure that we don't pour in enormous resources and try and finish everything, because this project is meant to be advancing this to a point where we can apply for funding, if you see what I mean. Ideally, we'd publish something, obviously, as a complete piece of work. So the chemistry we're doing, I think, is going for that, absolutely. We're trying to zoom in on the active compounds, and the MOA is crucial. So I think we're doing all the right things. Just be aware that ideally what we'd go for is a sort of publication in the short term and a clarification of what needs to be done if we had some more money.
Is there anything else we could do for mechanism of action then?
Well, there is, if we sent in active and inactive for a kinase panel or something, we could get that done. I think our UNC friends would do that for us. So they'd send that to in one of the kinome panels that they run every now and again when they've got a spare row, kind of thing. I could definitely ask for that, in fact.
What about the seeing the metal binding potential of these, just as a general precaution?
Absolutely. I think there's no doubt that if we do that NMR experiment and we add in a metal, we're going to see something, because it's coordinating. I guess I'm not quite sure what we read into that, or whether what we need to be doing is trying to identify any known enzymes which are known to bind motifs like this in an active site. Let's say there's a metalloenzyme which is susceptible to things like this. Is there any way of zooming in on that? Or is there any target which seems likely based on similarity of structures of these molecules that we're working on with other things that are known? I don't know. Because of course, what you really want to do is some experimental thing which maybe flag something up as a potential target, ideally. I don't know. Yeah, it's a really good point, I think. I mean, what if the UNC stuff comes back blank or uncertain or unclear? It would be nice to have a plan B. Kinase panel being one obvious thing. Any other evaluations we could do?
Do you guys have any experience with CETSA assays?
Those are
the cellular thermal shift.
Yeah, those are the ones that I think that Lee Graves can also do.
Okay, cool. Because I know that like the RSC and other organizations have these like kind of smaller dollar awards and things that you can apply for, which would maybe fund, 1 or 2 experiments like that. If it's not under the purview of the Farm Alliance grant.
Yeah, right. I mean, thinking about available screens beyond like COAD and beyond like arrangements on kinase panels and stuff like that. What else can you? The NCI used to have a cancer cell line, a bunch of cancer cell lines, right, that you could submit compounds to, which we could also have a go at. Things that are available where we can ship compounds and have them done. What are we missing? Something there? I don't know, Chris. I'm out of date with the NCI panels.
Yeah, I don't know about free ones, but I mean there are commercial ones where you can submit a compound and they will put it through a vast number of assays, but you pay for them.
What's to the nearest 1,000? What are you talking about?
Probably something like 3 to 5K.
Yeah. Right.
Another sort of possibility is you could set up a competition for people for in silico prediction of mode of action or likely target.
Yeah, that's the kind of thing I was thinking. I mean, we had a lot of interest in that on Open Source Malaria Series 3 when Todd was asking about that. People really just went for it.
Yeah.
And you never know what's going to come up. Sure, we could frame it as that. And I guess we have maybe enough data now for that to be useful. Lots of inactives, lots of several actives.
Yeah.
It's not bad.
So we're not asking for them to predict compound. What we want them to do is predict the target.
Yeah, absolutely. I mean, I don't know if perhaps we should wait until we've got the tox data so that we know if we're.
Yeah, I think that's fair. Yeah, I think that's fair comment. I mean, I think you wouldn't want to set up all the program and then find out all the compounds are toxic.
Yeah. Okay, but it's sensible to try that.
Yeah.
And I think to some extent, Lee Graves's experiments are biased towards kinases already. So I think the targets they're looking at are mostly those. So we'll wait and see what comes up there, and then we can think about maybe doing that more generally. But I think it's a great point. Yeah, it is ultimately something we need clarification on.
Yeah.
Okay, I think that's everything. Thank you. That's been really useful.
When is the ETA on the tox data?
About 3 weeks, I guess.
3 weeks from now. All right.
I think so. Something like that.
Okay.
See how it goes. We'll keep everyone posted, I guess.
Yeah.
Any updates on that, Ed? Just pass them right along. All right. Thank you, everybody. Nice to see you.
See you then.
See you again soon.
Right. Bye.